Hey guys, Miss Altman here. I am going to be going through some example problems of the chapter Chemical Quantities. These are some problems that will help you get through the mole-to-mole problems assignment. Basically what we're doing in this unit is we're taking all of the T-charts, and technically it's called stoichiometry, that we did in the last unit, and we are going to combine that with balancing chemical equations. Now, for the assignment for today, your equations are already balanced for you. However, I'm just going to go ahead and write them out unbalanced so that we can remember and get some practice on how to balance equations. So here I have in the equation water yields or will break down into hydrogen gas and oxygen gas. Okay. Now this equation is not balanced. I'm going to go ahead and balance it. So I'm going to draw my line here at the arrow because everything in front of the line has to equal everything behind the line. Okay, so on the left-hand side, I have 2 hydrogens and I have 1 oxygen. Okay, over here on the right-hand side, I have 2 hydrogens and I have 2 oxygens. So obviously, this is not balanced because even though my H's are balanced, my O's are not. So this is a pretty easy fix. If I need 2 oxygens on this side, I'm just going to go ahead and stick a 2 in front, which gives me the 2 oxygens that I need. Okay, however, because oxygen is not on its own over here like it is here, I also have changed the amount of hydrogens I have. So if I started with 2 and then I doubled that, I now have 4 hydrogens on the left-hand side of my yield sign. Okay, which is what that is. Now, my oxygens match, but my hydrogens do not. Now this is an easy fix. If I have 2 over here and I need 4, I'm just going to stick another 2 because 2 times 2 is 4. So now this equation is balanced and I can use it now. Okay. So what this tells me is that for every 2 water molecules, I will make 2 hydrogens and 1 oxygen. Okay. So 2 water molecules makes 2 hydrogens and 1 oxygen. Okay. Now, these are compounds, and I refer to them as hydrogen and oxygen, even though they are compounds. Though this hydrogen compound has 2 hydrogens in it, this oxygen compound has 2 oxygens in it. But once they're together, we're not going to pick them apart. Okay? So, for every 2 molecules of water, I get 2 molecules of H2, and I get 1 molecule of O2. What this also means is that for every 2 moles of water, I get 2 moles of H2 and 1 mole of O2. Okay, so I can use this as a conversion factor. So if you remember in the last chapter, we talked about we had 1 mole equals 6.022 times 10 to the 24th. That's called a conversion factor. When you say something equals something else and then you use that to change between units, those are conversion factors, okay? So we have just found our conversion factor for this problem, okay? So let's pretend that I have 14.5 moles of water, okay? I want to figure out how many moles of oxygen I make. Okay, so I'm going to draw my T-chart. Okay, and I'm going to start up here with the thing that I know from the problem, the number that I was given. And the number that I was given was 14.5 moles of water. Okay, now if I have moles of water up here, I have to have moles of water down here. Okay, and then if I go look at my conversion factor, I know that 2 moles of water make 2 moles of this and 1 mole of this. So my conversion factor here is 2 moles of water. Okay, now I'm trying to get to moles of oxygen. So I know that 2 moles of water makes 1 mole of oxygen. Okay, now if I put this in my calculator, this unit will cancel out that unit, and the unit that I'm left with is moles of oxygen, which is what I'm looking for. So if I put that in my calculator, it's going to be 14.5 divided by 2, which equals 7.25 moles of oxygen. So if I had 14.5 moles of water, they would make 7.5 moles of oxygen. Okay, so let's figure out how much hydrogen we'll make. So same problem, but this time, how much hydrogen will I make? Okay, so draw my T-chart. I'm going to use the number that was given to me in my problem, so 14.5 moles of water. I'm going to, if I have moles of water here, I have to have moles of water here. Okay, and then using my conversion factor from my balanced equation, I can see that 2 moles of water, and I'm looking for hydrogen, makes 2 moles of H2. Okay, and then I'll put equals. All right, so what I'm going to do is I'm going to say 14.5 times 2 divided by 2, which is just going to equal 14.5 moles of H2. Okay, now there's a couple of really important things for doing these problems. These are called mole-to-mole conversions. First of all, once you have balanced your equation, do not pick it apart. Okay, so for example here, when I said 2 moles of H2, I'm not going to pick this apart and say, well, I have 4 hydrogen molecules. No, no, no. Once it is balanced, you do not pick this apart at all. Okay, these become units that stay together. Okay, they're not going to break apart anymore. So I have 2 H2Os and I have 2 H2s. Okay, so don't pick those apart. Also, another thing that will help a lot in these is to over-label everything. Okay, because these are going to get a little bit complicated and you don't want to get lost in your labeling. Okay, so let's do a little more complicated one. All right, so if we have 4.3 moles of C3H8, how many moles, or let's just say how much, no, how many, of the product are made? Okay, so that's our question, and then I'm going to give you your equation. So it is C3H8 plus O2 yields CO2 and water. Okay, so this equation is not balanced. So I'm going to go ahead and draw my arrow, and over here I have C's, H's, and O's. I've got 3 of those, I've got 8 H's, and I've got 2 O's. And then over here I have C's, H's, and O's. I have 1 of those, I have 2 of those, and I've got 1, 2, 3 of those. So I'm going to start with my carbons because they're easy. If I put a 3 right here, that will give me the 3 carbons that I need. Okay, but because carbon's not on his own, it's going to also change the amount of oxygens that I have. So if I had 2, I'm doubling, or I'm tripling that, so now I have 6 oxygens, and then adding that one on, I have 7. Okay, so now let's do our hydrogens, because this is an odd number, and I don't like that. So let's do our hydrogens next. I have 8 over here, and I have 2 over here. So that's an easy fix. If I put a 4 here, that will give me 8 hydrogens on this side. But that also is going to change my oxygens. So if I have 6 here, and then I now have 4 here, that means I have 10 oxygens on this side. So let's make the oxygens match here. So if I have 2 here, I can just stick a 5 in front and give myself 10. 3, 8, 10. My equation's balanced. Okay, so what this means is that 1 mole of C3H8 plus 5 moles of O2 yields 3 moles of CO2 and 4 moles of H2O. Okay, so if we have, instead of just 1, what if we have 4.3 moles of this? So let's see how much CO2 we would make. Okay, so I'm going to scoop this up. So I'm going to start with my T-chart, and from the problem I was given 4.3 moles of C3H8. Okay, if I have C3H8 up here, I have to have moles of C3H8 down there. Okay, now going back to my balanced equation, I know that 1 C3H8 gives me, I'm looking for CO2, gives me 3 moles of CO2. Okay, My moles of C3H8 cancel, and I'm left with moles of CO2. So it is 4.3 times 3, and that is going to give me 12.9 moles of CO2. Okay, so what this is saying is normally 1 mole of this and 5 moles of that give you 3 moles of CO2. Okay, but if I have 4.3 moles of this, I'm now going to get 12.9 moles of that. Okay, so let's do the H2O. Okay, so again, in my problem, I was given 4.3 moles of C3H8. Draw my T-chart. If I have moles of C3H8 up here, I have to have moles of C3H8 down here. Okay, and so from my problem, I know that 1 mole of C3H8. I'm trying to get to H2O, so I have 4 moles of H2O. If I plug this into my calculator, this cancels that, and I'm left with moles of H2O. So 4.3 times 4 is 17.2 moles of H2O. Okay, now you can also kind of go backwards with this, okay, because we were saying if I have this many moles of this, okay, well, I know that 1 mole of this needs 5 moles of oxygen to be able to do the chemical reaction. So if I have 4.3 moles of this, I have to have more oxygen too. So let's figure out how much oxygen I need to have if I'm going to use 4.3 moles of C3H8. So I'm given 4.3 in the problem, and let me move up so we can see. There we go. So I'm given 4.3 in the problem, okay? Now if we look back at our conversion factor that we have done, I know that 1 mole of this needs 5 moles of oxygen, okay? So 1 mole of C3H8 needs 5 moles of oxygen, okay? The moles of C3H8 cancel, and so I'm left with moles of oxygen. So 4.3 times 5 is 21.5 moles of oxygen. Okay, so that is how you work mole-to-mole problems. This should help you go through your equations. Just remember that you're not picking anything apart. Okay, so this is 5 moles of O2. This is not 10 oxygens. Okay, don't pick this back apart. Once you have it balanced, and on this assignment they're already all balanced for you, don't pick them back apart. Okay, you're only using the numbers that are at the front. Okay, so I'm going to go ahead and stop talking and let you guys get to work, and please email us and ask questions if you have any. Bye guys.